Okay, so spent some hours slowly bringing this power supply up. It's just fine. This capacitor seems to be formed just okay. But I thought go over a couple of things about this. Right now, the meter's disconnected. We'll get back to that in a moment. Oh, pardon me. Thought I'd simulate some of what one can expect with a trouble. In this case, the trouble will be a dead short across the power supply. Now this is after the rectifier. The results would be the same if it were before the rectifier. A shorted high voltage winding from this power transformer will do this. This results in the same thing. I'll get a little bit into that. So the meter probes are tied directly across the first capacitor, the rectifier circuit, first filter capacitor. If some of the other ones further downstream are shorted, that can be a little bit more difficult to notice with this crude ammeter. So anyway, let's see, variac turned all the way down, power on, turn the variac up a little bit. Let's see, variac, let's give it 50 volts. So you can see this 60 watt lamp here is fairly well lit, and this pilot and this pilot are not lit because of this short. If I undo this, I'm not going to. This would dim. The reason I'm not going to do that, I'll explain in a minute. This would dim and these would begin to glow. I'm going to put this all the way up, 25 volts into this. Nothing coming out of the filament supply for this tube. Nothing filament supplies for the other tubes in this lamp. And this 60 watt bulb is pretty full well on. That's putting a little stress on this. The secondary current's probably a little higher than you want to sustain over a long period. But just to give you an idea, if you got a dead short and you got full power, it looks like that. Okay? So I'll remove this dead short, and I'm gonna step down to a smaller ballast. This is a 15 watts lamp, and of course this will do the same thing. Yeah, demonstrate it anyway. Shoot, why not? Dead short, and what we can expect: full power, switch on, right, 15 watts. Now this could sit like that for forever and it'll hurt nothing. But notice, neither of these are lit. There's nothing left in the secondaries of this because the biggest one, the high voltage one, is dead short, basically. It is through this rectifier. If I pull this rectifier out, that will get very dim very quickly, as we've seen before, but I don't want to do that for reasons I'll get into in a minute. So power off, all the way down, remove this bleed dead short. And put these back into the meter so we can read some DC voltage. Again, these are tied across the main DC supply, B+ on this guy. So, pardon me. Let's see what I want to show. Oh, I've already, as I said, I've already gone through reforming this cap. It was uneventful. Set it, raise it 20 volts on the meter here, which is what was voltage across the caps. Let it set for a half hour, raise it another 20, let it set like that, and didn't see any troubles. Didn't expect to. If I didn't know anything about this amplifier and its history, I might have been paying closer attention to that stuff, but then I did go and get this smaller wattage lamp and put it in there because walking away, you know, something went terribly wrong, it wouldn't smoke or get hot or burn out my iron or anything like that. So right now it's got, it's interesting. Three-tenths of a volt and rising. 3/10 of a volt and rising. I suspect, because I've been dorking around with things, a little bit of residual charge left in this cap. But anyway, I got it all the way up full Monty with this cap, with the strong 60-watt ballast. No troubles with it at all. But I thought I'd maybe illustrate some of it with this. What happens? It's got no other tubes in it. It's just this solid-state rectifier. And I thought maybe it'd be useful to show the difference between the solid state and a little bit more about the solid state versus the vacuum tube rectifier, which, oh, it's somewhere around here. There they are. And how they react as far as inrush currents and so forth, and what you can expect of DC voltage, even without tubes, otherwise drawing current. So, let's see. Variax turned off right now. I'm going to crank the voltage all the way up. Right now, the line voltage into this is about 125 volts. It tends to be a little high. And keep in mind, 15-watt ballast in series with a line. Power on. Okay, so these seem, I'm not going to measure the voltage on them, but yeah, they seem to be pretty normal brightness, what you'd expect. This is across the, with a resistor in line with it, across the tube filament supply, 6.3 volt. This 5-volt lamp is across 5 volts for the rectifier. Well, that looks about right. And across this electrolytic, at least the first section, 327 volts. Well, let's call it 330 volts. And for a 15-watt lamp, that's, you know, precious little glow coming from it. It's certainly not drawing 15 watts right now. Indeed, even just removing this pilot lamp reduces the glow of that some. Certainly removing this does. Not a whole lot, which is what you'd want. And the high voltage across this capacitor, the DC, removed the supply to it, but it's very slowly coming down. That's what you'd expect. I think right now with this amplifier, the only load on this capacitor, other than its own internal leakage, is this meter, which is probably something like 15 megohms. So, let me slug this back in. Slight boost to that while it recharges this cap. Yeah, slowly comes up, comes up, comes up. And there's no reason why this capacitor would ever complain about that voltage. It's 400 volts rated for all of the sections that are still connected in. Okay, so pop this pilot back in. And so what happens if we put in a stiffer ballast, the 60 watt? Yeah, no light there at all. It's not drawing enough current, so there's not enough voltage drop across this to make it even glow. But we've got 400, let's call it 430 volts across this first section of this capacitor. It's not complaining yet. I wouldn't sustain that. That's within the surge rating of these, generally speaking. Being rated for 400 volts, that's not crazy. But keep in mind, we're reading that this power supply is not loaded, and it has a solid state rectifier in it. So that's what you could expect. So I'm going to knock this down a little bit. Just keep it below 400 volts. Keep Mr. Electrolytic here fat, dumb, and happy. Okay, so tubes. What we hear? Here's the rectifier. Alright, let's say we put this so that with the ballast, 60 watt ballast, we get 400 volts on the main supply, B+. I said 400, not 399. Okay. And we'll swap this in. It's 5Y3 rectifier. Line voltage wanders about, so I'll pull this and pop this in. Checking. Heater cathodes are coming up. These are 5Y3 has directly heated cathodes. They come up pretty quick, and they're nothing out of here. And 365. Why did it set to 400? Well, that's the drop. The difference between the vacuum tubes and these solid state kludges makes quite a bit of difference. Also, I'm going to put the 15-watt lamp back in as ballast. And a couple of things. Quite a bit brighter with this vacuum tube rectifier in it. And the voltage, it's kind of saggy. That could be of some use in some circumstances. Right? So let's call it 260 with the tube in it. And some brightness. I'll put the solid state rectifier back in. Very low glow. And approaching 300 volts. So the heater cathodes in this draw quite a bit of current. It's not crazy, but it's higher than this tiny bulb here. So the ballast is not dropping as much voltage as it does with this in there. And let's see, let's call it 300 volts with the solid state rectifier. Very little current draw. Go ahead and stick this in. A bit higher. Without current draw. And it's all because of the heater. Or the heater cathode. And because of that higher drop with this ballast in there, you're going to get a lower B+ voltage, of course. So, I'm going to seat him all the way in, because I think you know, maybe not. Maybe not. I changed my mind. I'm going to pull him out. And I'm going to sock in the solid state one. Okay. I'm going to go yeah, I'm going to go full up with the voltage with the 15 volt, I'm sorry, 15 watt ballast lamp. That's not overvolting the capacitor at all, not even close. And let's see. Plug in one of the output tubes, or two, of course. This is a Class AG1 output push-pull 6V6s. And these are matched, at least date-wise. Boy, they look like they're hardly been used. So, anyway, I'm just going to plug one of them in, which is going to draw some more current from the heat because of the heater, and then start drawing current from the B+ supply. Cause this to drop, this to light up more, which it is doing. Yep. I'm surprised that works as well as it does with that ballast in there. You can see what B+ is doing. It's coming back up. Interesting. So that's B+ we can expect under these circumstances. It's a bit dim, so the output voltages of this are quite low because of this ballast. But But even with that, this 66 is doing something. It's drawing current. Good sign. So 161 and change. I'm gonna real quick pop it out of that socket, put it into this one. What's it do? I should expect similar results. Let it settle, move around a little bit. It's coming back up. Yep. These lamp ballasts are kind of dynamic things, so I do have to give it some time to set up. So I'm going to call that one. It is 59 and change. Okay. Pull him out and jump back up. That tube's working. At least at these low voltages. Let's pop that in. Current comes up because of the cathode heater. And as the cathode warms, begins to conduct. Whoa. It should come back up. Yep. Wow. Pretty closely matched pair, at least, at the voltages they're seeing now. Plate voltage being no more than 152 volts. Yeah. Boy, that would be lovely. Interesting. Alright, so I'm going to put both of these in. Fully seat them. And I would expect that to go down. Just to get a bit brighter. Interesting. Right. At 50 volts B plus. Let's up the ante a little bit. Take the 15 watt ballast out and put in 60 watt ballast. Yeah, we get some volts on those plates. Not too bad. Call it 230 volts up on the plates. Yeah, tubes are warming. The heaters are not fully struck because of this ballast. So I'm gonna suspend this right now for no other reason than I want to break this into chunks. Much easier to process.